We're going to look at some more graphing of secant and cosecant. For this first problem, it says to use the equation y is equal to 3 times the cosecant of 2x to identify the following and then graph the function. We need to identify the amplitude, the orientation, the period, and where the asymptotes are located. Some of this stuff we can get directly from the equation. All of it comes from the equation, but some of it is easier to get when we actually go ahead and graph this function. The first thing is the amplitude. Amplitude is our A. These are the parent functions that we're dealing with in this section. We haven't done any horizontal or vertical shifts yet, so the only thing we're changing at this point is our amplitude and our period with our omega. So this 3 is our amplitude. Remember, amplitude is a distance. And orientation is also somewhat based on the 3. It's based on whether that 3 is positive or negative. So this one happens to be positive. So therefore, our orientation will be positive. Period is the number of cycles that would occur between 0 and 2 pi, since that is the period or the length of one cycle for the parent function. And it's based off of your omega value. So this is telling us that we would have 2 complete cycles from 0 to 2 pi. Therefore, our period would be pi. But another way to find it is you can use this equation t is equal to 2 pi over omega. And then just substitute in omega. 2 pi divided by 2 will leave us with pi. So our period for this is pi. That means that one full cycle of our cosecant will go from 0 to pi. And then the asymptotes, that part is more difficult to get from the equation itself. It's easier to find from the graph, I believe. You essentially have to figure out where is cosecant undefined. Now, remember that cosecant is the reciprocal to sine. Therefore, this graph is related to y is equal to 3 times the sine of 2x. What I'm going to do is I'm going to sketch out that graph and determine where my y values are 0, because that will tell me where I have something that's undefined, since 1 divided by 0 is an undefined value. And that will be where my asymptotes will occur. Since I have a period of pi, I know that I'm going to have one cycle between 0 and pi. I'm going to end up going by pi over 4. So pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. And now I know that one full cycle goes from 0 to pi. And I'm dealing with sine. I'm going to sketch that reciprocal function. Since it's positive, we know we will go up first. And for a sine function, the sine function starts at the origin at 0, 0, and it ends a wave back on the midline. Halfway in between those two endpoints is also a point on the midline. Then, halfway between your first point and your middle point, you always go up to a maximum. Or if it's negatively oriented, you would go down to a minimum. And halfway between the next 2 points, we would go down to our minimum. So this is what our sine function that is related to this cosecant function would look like. And remember, the pattern just keeps repeating. So we could continue this graph if we wanted to and keep having it continue. Notice you have one cycle and then a second cycle in a distance from 0 to 2 pi. That has to do with that 2 there. So now where will our asymptotes be located? They're going to be located at 0, at pi over 2, at pi, at 3 pi over 2, at 2 pi, and it keeps going on really in either direction. So now I'm going to draw in my asymptotes here. And now we can go and use this sine function to help us graph our cosecant function. You go to that maximum point, and then we essentially get a little bit of a U shape, kind of like a parabola. Go to our minimum and do the same thing. It opens downwards now. Maximum and a minimum. And we could continue that over and over and over again.